Okay, so this is our domain and range notes. This is day 4, domain and range notes. So with your pencil, make sure you're writing everything that I'm writing down here. First, we need the definition for domain. So domain is the set of all x's or inputs covered by a line or real-world problem. The variable x is often used to represent the domain, and we'll talk about the domain more in the following problems below. Alright, so range is the set of all y's or outputs covered by a line or real-world problem. The variable y, or you're often going to see function notation such as f of x or g of x, some type of function notation representing a function is often used to represent the range. Alright, so now we have the terms discrete and continuous. Now a discrete situation or discrete function is a real-world situation where things are counted. So like we're going to talk about videos on TikTok. A video, number of videos, that's counted, okay? Therefore, the points are disconnected therefore the points are disconnected, so there are dots on the grid. So when you have a discrete situation, you're going to see data points, but the dots will not be connected. Alright, then you have continuous. Now continuous is a real world situation where things are measured. Therefore the points are connected to form a line. Now it'd be a good idea right now to go ahead and pause the video, and then I want you to read these to yourself kind of out loud. That way you'll get the jargon down. Alright, so here we go. So let's look at a real world situation here. Okay, so we have TikTok followers. So Dustin tracked his number of followers on TikTok after each video he posts. The graph below shows his data. Alright, so anytime we're looking at a graph, remember we want to see what the x-axis is and we want to see what the y-axis is. So the x-axis, this is going to be the video number. So he posts his first video, then his second, then his third, and so forth. And then this is going to be the total number of followers after each video. Okay? Alright. So notice on here, the dots are disconnected. It doesn't make sense to connect these dots with a line because there's no such thing as half a video. And also videos are counted. So this situation represents a discrete function, okay, because followers are counted. So the data is shown by disconnected dots. Disconnected dots, okay? So again, we do not connect these dots because we count the number of videos, we also count the number of followers, and it doesn't make sense to have half of a video or to have half of a follower, okay? Alright, so the domain for this function is going to be all the x values for each dot. And when you have a discrete function or discrete situation, you're going to write the domain separated with commas, okay? Each x separated with commas. So the domain, the x's along the x-axis, is the following set of numbers. So the first one is going to be 0. The next one is going to be 1, 3, see, this will be 4, 5, 5, 6, and of course 7. Okay, and then we put them in the brackets like this for set notation. So the domain is the axis along the x-axis, and the following set of numbers: 0, 1, 2, 3, 4, 5, 6, 7. Now the range is going to be the y's along the y-axis, and it is the following set of numbers. Okay, so for each dot we're going to put the y value. So for this dot we're going to put 0. For this dot we're going to put 10. For this one we'll put, that looks like 25. And then for this one that looks like 45. And then for 4 that looks like 60. 5, that'd be 65. And then for 6 that'll be 80. I wrote a little too big here. And then for 7 that will be 100. Okay. All right, so this is going to be our range. So this will be the range for the function. Remember, the range is along the y-axis. All right, so let's flip over to the next page. Okay, so now let's look at this situation. Remember, you always want to read the situation, okay? All right, so Logan spills a 40-ounce can of the latest Prime energy drink. The graph below shows the rate at which the drink drains from the can. Okay. All right, so notice along this is my x-axis. That's going to be my time in seconds. And then this is my y-axis. So that's going to be ounces remaining. Okay. All right, so let's answer our first question here. So the situation represents so notice we have a line. Okay, we have a line. So we have all these different data points, but they're all connected with a line. So this is going to represent a continuous function because ounces remaining, okay, because ounces remaining in a can are measured. All right, we're measuring how much is remaining in the can that Logan spilled. So the data is shown by connected dots to form a line. Okay, so now let's talk about the domain. So here the domain, we're going to write it two different ways. So remember, the domain is our set of x's. So the domain here goes from 0 on the x-axis all the way over here to 10. All right, so I'm going to color what the domain is. So the domain is going to be everything that's gold, all the x values that are gold. So it's going to be 0.25, 0.78, all right, 1.25, 1.5, and so forth. Okay, so it's going to be any number in between 0 and 10. So to write the domain, we're going to write it like this. So the domain is 0 is between 0 and 10. So x is greater than or equal to 0. X is also less than or equal to 10. Now another way to write the domain is the following. We can say this. The domain is the set of all real numbers greater than or equal to. Notice this is greater than or equal to. So we're going to put 0. X is greater than or equal to 0, and it's also less than or equal to 10. So x is less than or equal to 10, so we will put 10 right there. So make sure you understand these phrases. Greater than or equal to, okay, that's this one. X is greater than or equal to 0, and then less than or equal to. So x is less than or equal to 10. All right, so now let's talk about our range. Okay, so our range, again, is a set of y values. So our range is going to be from 0 all the way up to here, which is 40. Okay, so our range is going to be from 0 to 40. Now remember, range is your y's. So our range here is going to be from 0 all the way to 40. So our range is any number in between 0 and 40. So we can also write the range in function notation like this. Okay, notice we use function notation, so we'll put 0, 40. Okay, that's another way that we could write it. Where again, remember f of x is just replacing y. And so the range is a set of all real numbers greater than, okay, so again, make sure you understand this term, greater than or equal to. So y is going to be greater than or equal to 0. And at the same time, it's going to be less than or equal to 40. All right, it's going to be less than or equal to 40. All right, so on your test, you're going to see both ways. So you got to make sure you understand these words. All right, so writing the domain and range as inequalities. So again, these are inequalities. Notice we have the inequality symbols. Inequality symbols. So writing the domain and range as inequalities covers the decimals or fractions between the two whole numbers. So writing it this way, the y, or our range, can be any decimal in between 0 and 40. Okay? So this is a shorthand notation how we can write the range instead of listing out 1, 1.1, 1.5, and so forth. Okay? All right.